Hey guys, we're going to start with a warm-up that's going to help us get into this next section over radicals. So let's start with just reviewing how to do some multiplication things from Algebra 1 and Algebra 2. So we're going to start by distributing. I think Mr. Sharp actually used to call this FOIL. So you start with doing x times 2x. That would be 2x squared. Then you would go x times 3, and that's 3x. The next step would be negative 4 times 2x, that's negative 8x. And negative 4 times 3 would be negative 12, and then you would look for like terms. So your final answer for this would be 2x squared minus 5x minus 12. Okay. This second example, something different will happen. The beginning procedure, though, is still the same. So distributing, starting with n. So n times n is n squared. N times 6 is 6n. Negative 6 times n is negative 6n. And negative 6 times 6 is negative 36. And when you combine like terms, this is the different thing that happens. When you combine like terms, they cancel. So you end up with just n squared minus 36. This has a name. This is called a difference of squares problem. So what that means basically is that you have two identical parentheses, one with a minus and one with a plus. That's the word difference. Squares just means that they're identical. And the reason why it has a special name is because every single time you have something set up like this, the negative 6 and the positive 6 are going to always make these middle terms cancel. So it is helpful if you can recognize that that's going to be a difference of squares so that you understand what's going to happen when you do that multiplication step. And we're going to see something like that in this lesson. So again, it's not something you have to memorize. It's just helpful if you can recognize it. Last example, remember that when you square something, it means that you're multiplying that thing by itself. So this really just means z plus 4 times z plus 4. So you're going to set it up like such, and then you're going to multiply just like you've done with the first two problems. So this would be z squared plus 4z. And then when we go down to the second part, we get plus 4z plus 16. Combine like terms, and you get z squared plus 8z plus 16. Now, you'll notice that the previous example and this one are similar. The previous example, we had two different signs, one minus, one plus. This time the signs match, but the parentheses are the same. This one is called perfect squares. So the word perfect is implying that the signs are identical, whereas difference up here meant the signs were different. So a perfect square problem means that the two terms in the middle will not cancel, but they will actually double. Like 4 plus 4 is 8, whereas before we had 6 minus 6, so they went away. Again, it's just one of those things that's helpful to know. If you can recognize it in advance, it will kind of help you anticipate what's to come. Okay, so today's lesson is to learn about binomials containing radicals. This just means we're multiplying two parentheses, kind of like we just did in the warm-up. So I'm going to start you with 3 examples that are pretty similar to the examples we did in the warm-up. And I'm going to show you kind of, obviously walk you through the problems, but show you how they could represent things that we just talked about. So it's just multiplication. You are just going to have to be very careful in your steps and make sure that you're multiplying things correctly as they were introduced to you in the previous lesson. So this is what I mean. 4 times 3, those are just both regular numbers. So you would multiply them and you get 12. But like when you go to this step, 4 times 2 radical 7, you're actually only going to multiply the two constant or coefficient values. So you would get 8. And then there's no other radicals except radical 7, so that'll just stay radical 7. Next step is radical 7 times 3. This is a radical, this is not. So you cannot multiply them together and get radical 21, for example. You would just kind of put them together in one term and call it 3 radical 7. Last step, 1 radical 7 times 2 radical 7. So I'm going to multiply the outside numbers together, and I'm going to multiply the radical numbers together. So radical 7 times radical 7 is the same as radical 49. Okay? Now, just as we did in multiplying binomials, we will also have like terms. So we're going to look for those. So our 2 like terms here are 8 radical 7 and 3 radical 7. So we're going to add those together and get 11 radical 7. And then this particular problem does have one additional step, because radical 49 can be broken down to just 7. The square root of 49 is just 7. So we're going to simplify it further. And we're going to say, this thing at the end here has a 2 in front, but 49, square root of 49 is just 7. So we've got a little bit of work to do because we have some more simple math that can be done. So 2 times 7 is 14. And then we can combine like terms. 12 plus 14 would be 26 plus 11 radical 7. That's our final answer. All right, example B. Remember, when you square something, that means that you are multiplying that thing by itself. So the first thing I want to see from you is I want to see you writing out the binomial that's in the parentheses times itself like this. And then we're going to go through and multiply. Remember, outside numbers multiply together, inside numbers multiply together. So this first part would be 4 radical 9. And then we have 2, multiply the radicals together, you get radical 18. Then down here we get negative 2, and the radicals multiplied together equal radical 18 again. And then we have a negative times a negative, so a positive. Radicals get multiplied together, so that gives us positive radical 36. Next, you're going to look for like terms. We do have like terms here. So I'm going to have negative 4 radical 18 in the middle. And then hopefully you see a couple other things that you can do. Square root of 9 equals 3. Square root of 36 is equal to 6. So we're going to simplify those. We still have a 4 here, but like I said, square root of 9 is equal to 3. So that would become 4 times 3. And then square root of 36 is equal to 6. Almost done. 4 times 3 gives us 12. And then what we're going to do is try to clean this up a little bit. There's one thing I actually just kind of skipped over. I do need to add the 12 and the 6 together, but I kind of forgot to look at radical 18 and see if that would reduce. It actually does. I can take a 3 out and leave a 2 inside. So let me try to do this all in one step. I'm going to go back to 12 plus 6 would be 18, right? And then I'm going to take a 3 out, and the 4 that's already outside and the 3 that I'm removing would multiply. So that would be 12 radical 2. So there's your final answer. So I guess learn from my mistake and remember to check and make sure all of your radicals are reduced all the way down before you complete the problem. Last example, again, it's already set up for you, so you're going to go ahead and just start multiplying. Remember the rule, outside numbers multiply with outside numbers. Inside numbers multiply with inside numbers. So radical 5 times radical 5 would be radical 25. Next step, 4 times 3, that's 12. And 5 times 2 is 10. 4 times 3 again is 12. 5 times 2 again gives you 10. And then the last step is 3 times 3 is 9, and 2 times 2 is 4. Now, one thing I want to point out to you before I move on. I could have if I would have taken a moment to think, I could have stopped back at the beginning and saved myself a little time. Here's what I mean. If I would have recognized that this parentheses is identical to this one, and if I would have recognized that this is a plus and this is a minus, I could have identified that as a difference of squares. And that just means to me that I know that the middle terms are going to cancel each other out, okay? If you can recognize that in advance, then you don't need to multiply the middle terms together since you already know that they're going to cancel each other out, okay? So I'm going to just put a little note here that this is a difference of squares because it has the same parentheses, 1 minus and 1 plus. So I could have just gone and multiplied the first two things together and the last two things together. By no means is this required. I'm just trying to give you a shortcut if you want one. I could do the problem just as I have done and recognize then, oh, these two middle terms cancel each other out. So I'm just left with the first term and the last term, if that makes sense. But again, if you see and recognize that that's going to happen, save yourself a step. Okay, next I need to break down my radicals and simplify as much as I can. Radical 25 is equal to 5, and radical 4 is equal to 2. So I'm going to end up with something that looks like this. Remember, if you have an outside number, that would have to multiply by whatever you take out of your radical. So 16 times 5, I believe, is, what, 80? And 9 times 2 is 18. So our answer here, I believe, would have to be 62. So actually, the radicals completely disappear in that question. Okay, so we've talked before about radicals in the denominator and how it's kind of like a faux pas. You're not supposed to have radicals in the denominator. You need to remove them. It's like something we do to simplify radicals like you would simplify a fraction. Now, all we've seen thus far are things like, 5 over radical 3, which is like a single radical in the denominator. That's all we've seen thus far. So now I'm going to show you how to handle when you have a binomial in the denominator. Now, binomial, by the way, binomial is when you have two terms added together. So it could just be something like this with radicals, but it doesn't have to be with radicals. It can just be variables, but simply put, two things added or subtracted from one another is called a binomial. So in order to handle this scenario, what you're going to do is you're going to multiply by the conjugate. And the conjugate is taking the binomial and changing the sign in between. Okay, so this is called the conjugate. You're going to multiply the bottom by the conjugate, and because this is a fraction and we have to keep it balanced, you are also going to multiply the top by the conjugate, okay? Now, I'm going to go through and show you this example, so hopefully you see why this process of using a conjugate actually works. So I need to set it up. Let me get it set up first. I'm multiplying the top by 2 plus radical 3, and I'm multiplying the bottom by 2 plus radical 3 as well. That's the conjugate. Remember, just the same as the bottom, but change the sign. All right, let's simplify. The top, I'm distributing a 1, but that won't change anything, obviously. The bottom, a lot's going to happen, so let's be careful with our work. 2 times 2 would be 4. 2 times radical 3 would be 2 radical 3. Negative radical 3 times 2 would be negative 2 radical 3. And negative radical 3 times negative radical 3 would be negative radical 9. Okay, I'm going to ignore the top part for now, and I'm going to focus on the bottom. So first of all, you should see that there are two like terms, but they do cancel each other out. Now, why is that? Well, the reason they cancel each other out is because I chose to multiply by the conjugate, and the conjugate creates a difference of squares situation. Remember where the parentheses look the same, but one's a minus and one's a plus? That means that if we do it correctly, every single time we use a conjugate, the middle terms should cancel one another out. So we're getting closer to the goal of having no radicals in the denominator. Okay, so let me set this up and show you where we're at right now. We have 2 plus radical 3 on the top, which it's okay to have a radical on the top. And then the bottom is 4 minus radical 9. Now, right now I still have a radical in the denominator, so we're not done. However, the radical that I have in the denominator is what we call a perfect square, okay? Radical 9 is actually just equal to 3. So I can finish this problem by simplifying that radical on the bottom. That makes it turn into 4 minus 3, which gives me 2 plus radical 3 over 1. And then if it's just over 1, I can just call it 2 plus radical 3. Okay, so a conjugate will create a difference of squares situation, which will allow the radicals to cancel. Let's try another one. So here, just start with, I have a radical in the bottom. I need it to go away. So I'm going to multiply by the conjugate. Okay, you may also want to put these guys in parentheses so you know that they really kind of have to stick together. So we're multiplying here. All right, let's go through. This time we have to multiply on the top and get all this stuff figured out, and on the bottom, so it's kind of tedious. On the top, we would have 9 plus 3 radical 5 plus 3 radical 5 plus radical 25. Okay? On the bottom, now let me show you again. You can do this. You could save yourself some time. Here's what I mean. Look at the bottom. Do you see how it's a difference of squares situation? 1 minus, 1 plus, same exact parentheses otherwise. I know that the terms in the middle are going to cancel. So I'm going to choose this time to save myself some work. And I'm going to say all I need to do is multiply the first 2 terms together, which is 9, and the last 2 terms together, which is negative radical 25. Okay? If you didn't catch it, fine. Go ahead and multiply all of it through, but your middle terms are going to cancel, so you could save yourself that step. I'm going to go through the numerator, and I'm going to combine like terms, combine like radicals, because I do have a couple. The bottom, I can simplify, right? What's square root of 25? That's 5. Actually, I have another square root of 25 here. I wasn't paying attention. So let me go ahead and change this one also to 5. And then from here, you're just kind of combining like terms. So on the top, I have 9 plus 5. So let's make that 14. And then divided by 9 minus 5 is 4. This would be an okay answer. There's one thing we can do actually to make it better. And this does not happen very often, but I want to show you just in case. All of the numbers that are on the outside, so just not the radical, but all the numbers in front are actually divisible by 2. If all of the numbers, and it has to be all, if all of the numbers are divisible by the same thing, you can go ahead and divide them all to simplify the radical. So I could simplify this by calling it 7 plus 3 radical 5 over 2. Notice how the radical part did not change, only the numbers on the outside. Okay, almost finished. Quick review of function notation, because we're going to be using this next. Remember that the number on the inside represents x. So you would take whatever number's on the inside and you plug it in everywhere that you see an x, right? And then you just use PEMDAS. So 0 squared minus 0 would be 0. If I use negative 4, I'm going to be really careful that I plug my negative 4 in using parentheses so that I don't lose a negative somewhere along the way. So this would end up being 16, and that would actually turn into plus 4, so that would equal 20. You can plug letters in place of x. So if I have a inside, I'm going to put an a in everywhere that I see an x. And at that point, there's really nothing else I can do. And then this last one, be very, very careful. Everywhere you see an x, you're putting an a minus 1. Like this. So I would have to actually multiply a minus 1 times itself. And I would have to distribute this negative. So this is actually kind of a messy problem. I'm going to go ahead and do this a little faster. But I feel like you get the point at this time that you're just, have to be very careful when you're plugging things in using function notation. Okay, that was kind of the whole point of me showing you this. Here's what you may have to do. You may have to use function notation with radicals. In this case, it's a binomial. So this means everywhere I see x, I'm going to put a 2 plus radical 3. Okay, everywhere I see an x, I'm going to put a 2 plus radical 3. So this would be what my problem would turn into. I think I'm going to go ahead and simplify a little bit and say that this would be 3 plus radical 3 on top. And then I'm going to hopefully remember that when you square something, it means you're multiplying it by itself. So the bottom, actually, we have some work to do. So I'm going to multiply all this stuff and get 4 plus 2 radical 3 plus 2 radical 3 plus radical 9. Simplify. Whoops. There we go. Simplify a couple things. So on the bottom, you have like terms right here. You also have radical 9, which is just equal to 3. So I'm going to go ahead and do a couple things in one step. I'm going to combine the like terms and call it 4 radical 3. And then the whole numbers 4 and 3 can add and make 7. Okay. Unfortunately, with this problem, it's like the longest problem ever because you're still not done. You have a radical on the bottom. So we're going to have to use a conjugate now to get rid of that radical on the bottom. Remember, you just change the sign in the middle to make it the opposite of what your denominator shows. And you go through and multiply all this stuff. So we're going to end up with a lot, actually. The top would be 12 radical 3 minus 21 plus 4 radical 9 minus 7 radical 3. That's kind of a mess, but I'll clean it up here in a minute. The bottom, I do have a difference of squares situation since I was using a conjugate. So let's try to find a shortcut in this never-ending problem and just multiply the first terms and the last terms together. So that would give me 16 radical 9 minus 49. Since we already know the two middle terms are going to cancel. Almost done. Okay, so I'm going to do a couple things at once. I'm going to first recognize that radical 9 is equal to 3, which I have another one down here. So this is equal to 3. And then I also have like terms on the top. So the like terms would give me, what, 5 radical 3. And then negative 21 plus 3 would be negative 18. On the bottom, I have 16 times 3 is 48 minus 49. Almost done. The denominator, 48 minus 49, would be negative 1. You could leave it like this. This is fine. Or you could just go ahead and divide everything by negative 1. And that's just going to switch the signs. So either one of these answers here would be good. I think I will skip this problem for now because it seems a little bit excessive for what we're doing at the moment. And I'll just say you should have enough information now to go ahead and do your Delta Math assignment. Remember that Delta Math also does have videos that you can watch in each lesson if you get stuck and just need a little bit of extra help.